So in this video, we'll continue talking about classes and objects, but now we're going to add another part of object-oriented programming, which is very important, called inheritance. So the idea of inheritance, the word itself, inheritance, means getting something from our parents, genetically speaking, right? So you and I have parents, so most of our traits come from our parents. The same way we can represent this inheritance, genetically speaking, right? Getting traits from our parents, we can also do the same with objects and classes. So in this example here, we have, for instance, a class called ball, and then at the bottom we have baseball. If you look at the arrow pointing up, it means that the baseball here inherits from ball. So the ball in this case will be the parent class or the base class, okay? And then the subclass in this case will be the baseball. What this also means is that the baseball in this case gets all of the properties of a ball, gets all of the methods or behaviors of the ball. All right, so this is what we're going to be studying, looking at in this video here. All right, let's get into code and put this together. All right, so here we are back in our classes project here. Remember, this is a playground project. And so now we're going to talk about inheritance. So previously we were able to create a class. As you can see here, we created a ball class, has some properties, in this case, color and size. And we have our init method here, which takes in color and size. And then we initialize those values. We have behaviors, in this case, just one behavior, which is okay. And once we have all set up, we then create an instance of that class. In this case of our ball class, we call myBall, and we of course have to pass in our color and size because those are the values that we initially want our objects to have when they are instantiated. Okay, as you can see here, when we said print myBall dot notation here, so we're accessing one of the properties. Okay, in this case color, it gives us green. Why? Because in our ball instantiation here, as we create this myBall instance of the ball object, then we passed in green. Okay, so now let's talk about inheritance. So in order for us to inherit from, let's say, the ball class here, which means we'll create another class which will take all of these properties and behaviors, also the initialization, the init method here, we do the following. So what we do, we of course create a class. So we say class. In this case, we're going to call baseball. Notice that all classes naming start with an uppercase. Okay, and usually they are nouns, which means they only have one word. So baseball. Okay, car, vehicle. Now we're going to go ahead and put the colon, and then we're going to put the name of the class we want to inherit from. In this case, we want to inherit from the ball class. So here, what's happening again, we're saying ball class, which we're creating, inherits this colon here from ball. Of course, let's go ahead and have braces there, so we have a body there. And if you remember correctly, this notation here, we've seen this before. If you go back up here, you notice whenever we are creating variables here, we said var, color, and then we have the same notation, and we have string. Well, guess what? Internally, Swift is doing the same thing what we're doing here. Very implicitly, what we're saying here, we're saying color is of type string, meaning color inherits from string. You see? So this actually gives you another reason why, if you were to ask yourself, well, why is Paulo putting me through this and teaching me about all of these classes and objects? I don't care about that. I just want to build apps. Well, that's very true, and I understand that, but you can see that everything that we've been doing, it's all object-oriented, even when we create our own variables. Okay, good. So back to our baseball here, which inherits from our ball, which again means it gets all of the properties and behaviors as well as the init method here. Okay, it's empty for now. So what we can do, let's go ahead and create an instance of this baseball class. Okay, so let's go ahead and say var myBaseball is equal to baseball. Right away, we have an error here. So let's go ahead and click on this red here. It says missing argument for parameter color in call. Well, but you will say, well, what's going on? I didn't ask to put any parameter in our baseball class. Well, the reason why it's missing, it's saying it's giving this error is because my baseball here inherits from ball, which has all of these properties and behaviors and has this init method here inside. Since we are inheriting from the parent class, the ball, that also means we have to conform to what the parent class needs us to do. In this case, it needs us to actually pass on parameters which can be used to initialize our object. So in this case, we have to say color. As you can see, the moment you say color, it gives you all of the arguments that needs to be passed in order for this to work. So you say color and size. So type on string there. What color? Let's say, just say new color for now so we can say the difference. And tab, it takes you straight to the size. Let's say 123. Okay. And there we go. Now my baseball object here is instantiated. And we pass a new color, size. If we change here, say my baseball, there it is, say enter, color, is going to say new color because that's what we passed in here. And you can see this is the power of inheritance. We just said baseball inherits from ball, and it took everything that ball provides and made it its own. All right. Now you may say, well, what is the point then of inheriting from our parents, in this case, our parent class or our base class, the ball, if we could have just used ball, right? Well, it turns out there are times when you want to inherit from your parents, but as you know, we are not necessarily the copy of our parents. Sure, we have, same features, maybe the same nose, same type of hair, and so forth, but we have other things of our own. For instance, we have our own behaviors, right? We have our own level of intelligence and so forth. So there's a lot of attributes or properties and behaviors that are not of our parents. So we need to have our own. So that's the beauty here. So when we inherit from our parents, we're saying, well, we need all of those basic traits of our parents, in this case of our base class, so that we know we are indeed a copy of our parents, but we also want to be able to have our own traits or properties or methods or behaviors. So in the next video, we'll talk about overriding certain behaviors and properties of our parent classes so that although this new object here, the subclass, has all the traits of the parent, they can also have their own traits in addition to what they have inherited from their parents. All right, so great. So I'll see you then in the next video.